Welcome to the demonstration corner. Today we're going to talk about the measurement of specific heat and additionally discussion around thermal physical properties for the anisotropic or typically anisotropic pouch type batteries. Of course, this applies to prismatic batteries as well. The main part of our talk will be on large format batteries and how we measure the specific heat of them, and introduction to our newest large CP cell for pouch and prismatic batteries. But before we do, tradition here, we're going to just turn the camera around, show you the different instruments we have in our demonstration corner and a little bit about how they differ. This is a really important element of our company, is that we have a diverse range of methods, and we certainly have a general high level knowledge of each one and how to really figure out what is best suited for your application. So before we talk about the MP-1, which is where our battery testing is done, we have a battery package available on the MP-1, so we'll talk a little bit about that, but mostly focus on the specific heat cells. We will turn the camera to the GHFM-01. So this is guarded heat flow meter, following ASTM E1530 for measuring heterogeneous materials. This is really the only way, is a steady state method to measure materials that are heterogeneous. Otherwise, you are measuring some introduced error for other methods that are transient in nature. So measuring the resistance gives you a complete number representing a one-dimensional heat flow. So the guarded heat flow meter is ideally suited for measuring resistance and thermal conductivity. Typical sample size is 2-inch diameter. It is a one-dimensional heat flow. How do we know that? Because it uses a guard oven set to the mean temperature of the delta between the two plates that sandwich the sensor. The other ideal material that's suited for the GHFM is non-repeating layers. So non-repeating layers are composites that are disorganized. Those break the assumptions that transient methods use for measuring of this same type of material. So it's a rather key method. Thermal conductivity ranges from 0.1 to 100 watts per meter Kelvin. Plate temperature ranges -20 up to 310 Celsius. This is a pretty advanced, this is probably the most advanced guarded heat flow meter on the market. It has electric motors, electric control of the plates, as well as the guard oven. Uses a proprietary gimbal for closing with the ability to set to a pressure or thickness with a feedback optical encoder. So it's a really good instrument that really is underused. This is the other steady state method we have, which is our heat flow meter. The HFM-100 is, that stands for the thickness that you can introduce to the heat flow meter. The thickness, the maximum thickness for the HFM-100 is 4-inch thick or 100 millimeters thick. There's a few millimeters left, that obviously, so you can slide a full 4-inch sample in and out. The overall dimensions of this is 300 by 300 or 12 inches square. We have a HFM-50, which would be half the height, 50 millimeters, and its dimensions are 200 by 200 or 8-inch square. And then there's one more model, which is the HFM high temperature, so HFM-100 high temperature, which has a plate temperature of -30 to 110 Celsius. The standard HFM-100 and HFM-50 are plate temperatures of -20 to 75 Celsius. The other accessories you can add to this are the high TC kit for testing up to 2.5 watts per meter Kelvin, and the specific heat module for measuring direct specific heat. So if you know the thermal resistance and thermal conductivity and you measure the specific heat, you can calculate the thermal diffusivity. So that's designed for insulation and construction materials, where the guarded heat flow meter is designed for composites, metals, as well as heterogeneous materials. And that heat flow meter is following ASTM C518 and equivalent ISO standards. So, coming on the opposite side of the demonstration corner is our our THW-L1. This is for measuring thermal conductivity, thermal diffusivity, and specific heat, following ASTM 7896. The temperature range of the model we have here is 10 to 200 degrees, but the overall temperature range is can be packaged from -160 to 300 Celsius with the ability to back pressure 20 to 35 bar. That's really key for testing past boiling points, is the ability to back pressure that to test past the boiling points of your liquid. It also can be used for phase change materials. What makes this a primary method for measuring liquids and phase change materials is it is a small diameter wire suspended with that offers very little surface area, and with minimal temperature rise you get very little effects of convection, which is the enemy for measuring thermal conductivity. This is our small format ASTM C518, our HFM25. This allows you to measure small-sized insulation materials from 2 millimeters up to 25 millimeters thick, or 1 inch. And then our baby brother to the MP series, which is our MP-2. This is our economical or portable version of the measurement platform. It has available transient plane source sensors, transient hot wire sensors, and transient line source sensors for testing solids, liquids, pastes and powders, and soil. So that we have lots of demonstration videos on all these different instruments we've just mentioned. We invite you to check out our channel. We really do try to give advice and information on the use of them and why they exist as methods. So what we're going to talk about today is the specific heat cells for testing pouch batteries. Before we do, of course we're focusing on pouch batteries, but there is a specific heat module for cylinder type batteries, but we'll talk about that another day. Now there is also a demonstration video we have on measuring batteries that we do mention this and talk more about it. So this is the specific heat for measuring the 21700 type cylinder battery, which is 21 millimeters by 70 millimeters tall. That's the Maycore reference material. That would be the same dimensions as a cylinder battery that would fit inside that specific heat cell. But we're going to talk about specific heat cells for testing pouch batteries. So these are two of our standard sizes. How did they become standard is based off demand. So customers would approach us and say, we need a specific heat cell for testing a pouch battery of this dimension or this dimension range, and we would design a specific heat cell for that size, and that becomes part of our product offering. They all come with quick connects. What that means is they slide in to the sample holder that is included with the MP-1, which we'll talk a little bit more about. So they slide in. The insulation that is basic that comes with the specific heat cell is good to 80 Celsius. There's magnets that hold it together, so that it's nice and convenient. This specific heat cell for pouch batteries is 50 millimeters by 135 millimeters in length by 10 millimeters thick, or tall, I should say. And again, the way that these specific heat cells work is you would measure it empty, so you would run a reference with no sample introduced. You would have this connected to the adapter on the TPS method on the MP-1, which we will show you with our newest large CP cell. So you'd run the reference, and whether you're measuring a known material, so this is Maycore, this is the known material we include with a few sizes of the specific heat cells for pouch type batteries, so this is Maycore. The rule of thumb generally is you want to cover, again, because there is a dimension range that will fit each of these different pouch sizes or CP cell sizes, you want to cover at least half of the area of the surface. Of course, this covers more than half. This was designed for a particular battery type that covers closer to 90% of the area. And it's always a good rule of thumb to cover as much as you can, of course. So you would run your reference, and once your reference is done, you would introduce your sample or known material, put your lid back on, and run the exact same against the reference, so it'd be the exact same time. You would typically increase the power by 20% to just compensate for the added mass and volume you've introduced to that. You've introduced with your known material or your sample. So that's a basic discussion around how each of these work. This is good. The insulation that's included in the CP cell is good to 80 degrees, but the aluminum cell is of course good to several hundred degrees, and the sensor that's uniquely designed to fit each CP cell both the adhesive and the CP cell itself is good to 300 Celsius. So we offer an upgrade to the insulation, the basic insulation that comes with it. It's a high temperature insulation to allow you to take the same CP cell up to 300 degrees Celsius. And you can do subambient as well. So this is good to 80 Celsius, and there's an upgrade to the CP cell to go up to 300 degrees if you need it. The next dimension, which follows the exact same approach, so it has a 80-degree insulation, convenient pull apart with magnets. This has a custom sensor that covers the whole area of the bottom of the CP cell. This is 95 millimeters across, 138 millimeters in length, and 10 millimeters tall. It allows for a sample 10 millimeters tall. And again, if we were testing Maycore, this Maycore sample, this known material, that is sufficient coverage that you'll get really good data on that Maycore. So although, of course, we could add a much larger sample, this particular size allows a certain amount of flexibility. So we do have customers that do want more than one dimension of CP cell. So that's a conversation that you would have with us to determine, you know, do we have the dimensions of what you currently need, or do we need to make a custom CP cell? So when it comes to the custom CP cell, we can make any dimension up to 500 millimeters square. And that allows a lot of flexibility on different large format pouch type batteries. And we're seeing a lot more development of large format pouch type batteries due to just the market trends. So these are our two current sizes, and we have a new size that we're going to be introducing today. And we'll also talk about how the Quick Connect works with the sample holder, and we'll show you the high temperature insulation for the larger format as well. We have both of those for discussion. Okay, so we're going to bring the camera in, and this is the XPS insulation. And as well as the way it's shaped, it has ears. These ears allow it to hook into the sample holder and line up nicely without too much trouble. So by taking the lid off, it exposes the aluminum CP cell with the lid on. So this is empty. And the dimensions of this CP cell are 90 millimeters across and 300 millimeters in length. So, of course, that has a custom sensor design that has our 4 contact points, which we'll be showing you how that connects to the adapter. So, again, we would run a reference, which would be empty. And with increase in area or volume, the test time increases as well. So these test times are anywhere from depending on the size and the sample you have inside, or the sample you want to test. They're anywhere from 160 to 1280 seconds, and maybe even a little longer. So you would run your reference, and then introduce your sample, or known material if you're doing a verification step. So in this case, we have, for this particular dimension, we have a Pyrex known material we would introduce. As you can see, that covers the large majority of the area, and that has a really well-known value, and it's good to various temperature range. Again, the XPS is only good to 80 Celsius. So if you were going to measure above 80 Celsius, you wanted more flexibility on temperature. I'm just going to put this back together. This is the upgrade insulation for that exact same specific heat cell. So you'll see it has the same size as well as the same opening. Both of these have a foot, an extra foot, that when you slide it into the sample holder, it stays level. So both of them have a foot for that convenience. So this is the upgraded high temperature insulation. Of course, it would come in different sizes, but this can be added to any specific heat cell that we offer, whether it's cylinder or pouch type. And this XPS one has, of course, an XPS foot. So we're going to switch camera angles and just show you what that looks like. So here's our adapter. We talk about this adapter that plugs into the MP-1 plenty on other demonstrations. So we're going to show you how these 4 contact points from this large format specific heat cell slide in and make testing pretty convenient. So there's an opening. There's an opening at the front of that adapter Might be a little bit hard to see. We'll try there. And you just line that 4 contact points up with the opening. I'm doing this with extra hand. Now I'm going to lift the camera up. There's a window that exposes the 4 contact points, and as I slide this back, you can see the sensor cover those, and you know you have a fully inserted sensor. So that is sort of the electrical setup. And then once we turn this down, that lowers a plate and creates the electrical contact with the 4 contact points. So if I pull the camera back, that is a complete setup for an empty specific heat cell. And here you can see the ears, how they come in contact with the 2 bars. Now, of course, we've removed the top bar that would be present when we're testing a solid material. So this is the easy setup for measuring large format. You can see the foot that's here, and that's what allows us to extend and measure much larger sample holders. Now, if you're doing this with the 300-degree insulation, we would include this. You could put this in an oven. We offer ovens that would allow you to measure these larger sizes, or even perhaps your own. So, and if you're doing 300 degrees, there's a 300-degree adapter. This one is only good to 80 Celsius, which matches the temperature range of the insulation that's on this particular specific heat cell. So if you're upgrading to the ceramic insulation, there is an available upgrade to the adapter that's good to 300 Celsius, but it works identical, it's just constructed differently. So that concludes sort of discussion we wanted to have on the available specific heat cells that are available for pouches. There is a full demo video that we've done in the past on a little bit more in depth, but not so much discussion on the available sizes that are available. And if we can answer any questions, please get a hold of us. Otherwise, thanks for joining.